Alright guys, I need someone to call emergency services because I am on fire with videos today. Check it out, nuclear decay and half-life. How can you figure out the amount of a substance that's left after a certain amount of time? Here's your formula. In this formula, this is the amount left after a certain time has gone by. Amount left after a certain amount of time. We call that T in the equation. T is the amount of time gone by. A with the little tiny zero beside it, or A naught as I like to call it, is the starting amount, or how much you're starting with. I meant to say the initial amount. Now these can be in grams, they can be in moles, I don't really care, as long as they're in the same units. Half is going to be constant here, that's why it's called a half-life. Get it? And H is the actual half-life. This is the amount of time it takes for the substance to decay to half its original amount. We look these up in tables. Every single substance has its own half-life if it decays by a nuclear decay. We use this formula in the following way. Here's a sample of nobelium-259. It's got a half-life of 58 minutes. How much remains after one day if you start with a 1 kilogram sample? Well, the amount remaining is the amount you start with times a half to the power of T over H, where this is the amount of time gone by and this is the half-life. The amount we're left with is the starting amount. I'm going to write it as 1,000 grams. Times a half to the power of time. How much time has gone by? 1 day. What's the half-life? 58 minutes. Guys, I do not care what units you use in this T-H ratio as long as T and H are in the same units. Now, the half-life's 58 minutes and I've written it in minutes, so I've got to put the time gone by in minutes. But I was given that it was 1 day. Well, there's 60 minutes in an hour and 24 hours in a day. A day is 1,440 minutes. So, this is me writing a day in minute form. Then we put this into our calculator. 1,440 divided by 58. This is how many half-lives have gone by. We're going to take 0.5 to the power of that. How am I going to do that? 0.5 to the power of 1,440 divided by 58. I get this, and I multiply that by 1,000. See, times it by 1,000. Guys, the biggest mistake I see students make here, you've got to do this division in the exponent first, then do this exponentiation, 0.5 to the power of that number, and then multiply it by whatever your A naught is. Don't multiply this by a half, then raise it to the power. Use BEDMAS. Don't be a fool. The answer we get is 0.0000336. And I used grams, so this is in grams. If I was going to convert that, it would be 0.0336 milligrams, or 33.6 micrograms. I don't really care if you can do the conversion. I care that you can use this formula properly. Practice it, do it. Exponent first, times next. Here's the other kind of question you could be given. Dubnium-262, given the half-life of 34 seconds. But this time, instead of asking you how much is left, it asks how long does it take if to see 500 grams decay to 1 gram. Well, the amount remaining is the starting amount times a half to the power of T over H. We have 1 gram left, and we're starting with 500 grams. 1/2 to the power of, we don't know how much time has gone by. What we do know is that the half-life is 34 seconds. And I want you to solve this for the amount of time. Some of your teachers are going to say, yo, guys, just guess values of T until you get an answer of about 1. Sure, go for it. Guess and check, I don't care. I'm going to show you the better way. How do we solve for an exponent? Well, the first thing I want to do here is get rid of the 500 by dividing both sides by 500. 1 divided by 500 gives me 0.002 on the left side. These 500s cancel each other out, and you're left with 1/2 to the power of t over h, or t over 34. How do you solve for an exponent? This is me teaching you something. I'm also a math whiz, FYI. If you take the log of both sides, you can take this exponent and literally bring it down in front. So t over 34, which was the exponent, is now multiplied by the log of 0.5. And over here we have the log of 0.002. Yo, Chemist Nate, what's the log? Well, luckily for you, most calculators have a log button. This one does, and I bought it at Canadian Tire for like 10 bucks, so I'm sure yours does too. What's the log of 0.002? 0.002 log. Negative 2.698. Negative 2.698. What's the log of 0.5? Well, we'll do that on our calculator. We get 0.5, take the log of it, negative 0.301. Solve for t by dividing both sides by negative 0.301. These cancel each other out. You end up with 2.698 divided by 0.301, which gives me 8.96. And how do I undo division by 34? I multiply by 34. Sorry guys, I'm running out of room to move my arm. That's why I'm writing like a 12-year-old here. Times 34. I get a t of 304.8. Our half-life was given to us in seconds, so our answer is 304.8 seconds. That's how long it takes for 500 grams to decay to 1 gram. Again, you could have guessed and checked and figured it out, but I wanted to show you this little log trick because it gives you the exact answer down to the right decimal place. That video was longer than I thought it was going to be. Too bad, so sad. Best of luck.